Hi, welcome to ERC Technology, and this is the third part of our 8051 microcontroller tutorial series. Overview of 8051 family. The 8051 family consists of course, 8051, which is the original member of this family. It is also called MCS 51. We also have the 8052 and 8031, which are the other two members of the 8051 family. 8052 has all of the 8051 standard features, and it has extra 128 bytes of RAM, therefore making its total RAM as 256 bytes, and this is bigger than the 8051 RAM. It has also an extra timer. So instead of having two timers, we have three timers for 8052. 8052 also has 8 kilobytes of ROM instead of 4 kilobytes. So it's double. 851 is a subset of 8052. So all programs for 8051 runs on 8052. But the opposite is not true. So not all programs in 8052 may run in 8051, but all programs from 8051 can run in 8052. Now, in the case of 8031, this is referred to as ROM-less 8051 because it has 0 kilobytes of on-chip ROM. In other words, it has 0 KB of ROM. It has no ROM. There's no data inside its ROM. And in order to do that, we need to add an external ROM to it to use it. So we need to put our external ROM because it's ROM-less. So the ROM with program attached to 8031 can be up to 64 KB. It only has two ports for input-output operation and not four. So external input-output ports can be added to 8031 and with various speed versions available from different companies. Now this is the complete table showing you the comparison of the three. As you can see here, the serial ports for the three are all one, and also the input-output pins are all 32. But in the red mark here for 8052, you will see that it's double the ROM of 8051 and double the RAM of 8051. And for the timer, it has one extra, so it's three. And for the interrupts, it has eight instead of six. On the other hand, the 8031, in terms of RAM, timers, input-output pins, serial port, and interrupt sources, they are all the same with 8051. The only thing different with 8031 in comparison with 8051 is its ROM, which is 0K, or it has no ROM, ROMless. Now for the other 8051 microcontrollers, we have 8751. It is a 4 kilobytes UV EEPROM and requires access to PROM burner. The UV EEPROM eraser takes 20 minutes to erase the contents of the UV EEPROM. Another kind is the 8089C51 from Atmel Corporation. This is the most popular, inexpensive, and used in small projects. When you see 8089C51-12PC, the letter C between 89 and 51 stands for CMOS. It has low power consumption, and 12 means 12 megahertz. The letter P means plastic, and DIP, plastic DIP or dual inline packaging, and C stands for commercial in the last part. It has flash ROM, and this can be erased in seconds for fast development, and it requires ROM burner that supports flash. Now, the ROM eraser is not needed because this is done by the PROM burner itself. Now, another example of an 8051 model of microcontroller is the DS89C4X0, and there are variations of it. We can have DS89C4 20, 30, 40, and so on. And then it can be programmed via serial port of your IBM PC. It has a flash on-chip ROM. It comes with on-chip loader, loading program to on-chip flash via the PC-COM port. This is an ideal home development system. Another kind is the DS5000 from Dallas Semiconductor. This is an NVRAM version of 8051 in that it has the ability to change the ROM contents 1 byte at a time. And it comes with an on-chip loader that can be programmed via PC's COM port. Now, the ROM size of this is 8 kilobytes and it has a size of RAM of 128 bytes. Now, another one is what we call as the OTP or one-time programmable version of 8051. These are available from different sources, and its Flash and NVRAM are typically used for product development. And when a product is designed and absolutely finalized, the one-time programmable version is used for mass production since it is much cheaper in terms of price per unit. As it says, it can be only programmed one time. And I think most of the toys, cheap toys that children are playing with, are made of this OTP microcontrollers. Now, the 8051 family from Philips features A to D converters or analog to digital converters, digital to analog converters, extended I/O, and both OTP and flash. Inside the 8051, we have what we call as the register, which are used to store information temporarily, while the information can be a byte of data that will be processed, or it can also be an address that points to the data to be taken or fetched. Majority of the 8051 registers are 8-bit registers. And there's only one data type for this. Of course, this should be consisting of 8 bits. So as you can see in this drawing, the D0 is the least significant bit or the data 0, and the data 7 on the left side is the most significant bit, represented by MSB. And LSB means least significant bit, or it has the smallest value, and MSB has the biggest value. So with an 8-bit data type, any data larger than 8 bits must be grouped together or broken down into 8-bit chunks before it can be processed. That is the rule. So if you have 16 bits, it can be processed two times because it will be divided into two 8 bits data. Now, the major registers of 8051 are the following: accumulator for the A. This is used for all arithmetic and logic instructions. We also have B. We have R0 to R7. By the way, R means register. We have the 16-bit registers of 8051, and this includes the DPTR, which stands for data pointer, and this is used in accessing data. We also have PC or program counter. This points to the address of the next instruction to run or to be executed. Now, compilers produce hex files that is downloaded to our read-only memory of the microcontroller. And our main concern is the size of the hex file. So we have to take this into consideration because the microcontrollers have limited on-chip ROM, and the space for the code for 8051 is only limited to a maximum of 64 kilobytes. So C programming is used because it is less time consuming, but take note that it will produce larger hex file size. But why will we still use C programming instead of assembly programming? And the reasons for this are it is easier and less time consuming compared to write in C than and it's better to write in C than in assembly. So C is easier, again, as I have said, to modify, only not only to modify but to update. So you can also use the the codes available in function libraries, so you don't need to redo the wheel, or I mean write the specific programs for a specific function anymore, because these functions may be available in what we call as the function libraries, which are included in the start of our program. C code is portable. It means that you can transfer your code to other microcontrollers with little or with no modifications. Now, there are different terms here that follows, like machine language. This is a program that consists of zeros and ones. And programmers used this machine language before in the early days of the computer. But this is, of course, very difficult or cumbersome for humans. And that's what a machine language is. And later on, they developed the assembly language, which is a low-level language where the programmer don't need to write zero and one anymore, but they need to know all about the CPU registers or details about our computer. What is the size of its registers and other details about the PC. Now, the assembly language provides mnemonics for machine code instructions that made programming faster compared with writing it by zeros and ones. And it became now less prone to error. So it means that the possibility of having mistakes when writing zeros and ones in our programs will now be much easier, because you don't need to write zeros and ones, but instead we will be writing some mnemonics for our machine instructions. Now, the assembler is used to translate an assembly language program into machine code. And there's another one here, we call it low level language. Now, when it deals directly with the internal structure of the CPU. So, the assembly language is an example of a low level language. So it means that from machine language, it becomes a low level language, which is like the assembly language. And we need the assembler so that the program or mnemonics or codes that we write in assembly language will be converted back into machine codes or into machine language. So we write our program in assembly language and it will still be transformed down to the language of the machine, which is machine language. And to do that, we need to have an assembler. Now later on, instead of writing mnemonics, it becomes more English-like language where programmers don't need to be concerned with the internal details of the CPU. This is what we call as the high-level language. And what will happen now is we need the compiler to translate these high-level languages into machine code. Therefore, if the assembly language needs assembler, the high-level language like C language needs a compiler. That's why we have a C compiler. So that's it for our 8051 introduction or 8051 microcontroller introduction video tutorials in three parts. Thank you so much, and I hope you will subscribe, like, and share our videos towards our 1,000 subscribers goal.